Maybe I could just wait it out on Saturday because we will on the Saturday morning. You like Russia and you had already been hoping that's not
Okay, I think we are almost ready. So I will introduce Rafael, and we should, I think, start. So Rafael Volkmer, I guess I pronounced it correct.
Yes.
Okay, is the founder of Precious Plastic Vienna. He will talk about with us about this initiative and some other more general things, and the company they are starting in Vienna also. So welcome, Rafael.
Good morning. I can't see the audience. Maybe you can turn the so I have an idea. Hello. Good morning. Yeah, thank you for inviting me. Yeah, as you said, like the last 6 or 7 years, I was working with other friends, colleagues, people that I met in Vienna on an initiative called Precious Plastic. Can you just raise the hand if you know a little bit about precious plastic, if you ever heard about it? Okay, so almost nobody. Yeah, before I jump in, just like a few words about my background. So I studied long ago already now industrial design in the north of Italy, in Bolzano. And then I came to Vienna to get a master degree in social design, it was called, or is called. It's like a joint interdisciplinary course between architecture, the arts, design, but also with people from psychology or urban studies. So it was a very mixed master degree. And in this time, when I came to Vienna, I already knew that an open, Precious Plastic is an open source global initiative that has not really a leading person. It's more like a network. And I came to know a few years ago. And then in Vienna, we started a Precious Plastic workspace, and I will dive into this a little later. Those are the topics that I would like to tackle today. So some basic introduction about the plastic issue that mostly, I guess, most of you are aware of. Then I would just like to give you some very basics in plastic and recycling, because I think it's good to know what types of plastic exist, just to have like some basic common knowledge. Then I will introduce you to this Precious Plastic Global Network and show you how you can set up your own workspace. And then we dive into what we do at Precious Plastic Vienna. In the end, a little outlook to the company that we just started, coming from Precious Plastic, like from an association to a company. Yeah. So if we talk about plastics, I always it's in the recent years rather negatively connotated, because we all know that there is an enormous amount of trash pollution coming from plastics, or from wasting this resource. But on the other hand, without plastics, for example, things like medical applications or medicine as we know it today would not be possible, because a lot of things are just made from plastics that were before made from maybe stainless steel or from glass, and so they were not really so like not so widely like present in medical applications. Yeah, I will come to this later again. So the ugly facts, just like some basic numbers so that we get like an idea of how vast this plastic pollution is today. I got like, I'm not an expert into plastic myself. I'm just like by accident came to be. And I just searched for some numbers to get an idea. And so I found this number that actually by 2015, so the numbers are a little bit older, per each person living on the planet, there is 1 ton of plastic waste produced. So quite a lot. And most of this waste is not recycled or not. I mean, if we talk about plastic burned in the second paragraph, it's like for heat production mainly, I assume. But 70% are accumulated in landfills. And those landfills are often not in Europe or in Northern America, but they are somewhere in rural areas of like developing countries where they are just shipped to. And so basically, yeah, we just get rid of our plastic problem by shipping it somewhere else for like a long period. And this is also one of the reasons why plastic recycling was for a long time not a big thing, because it was just not happening. So before going into like the precious plastic network and so on, I just want to give you some basics. Like in the history of plastic, we could also say that things that are not like not the plastics that we know today, like oil-based plastic, but like things like you see here, like amber or bitumen, that were there already quite like a long time before, could also be assumed to be some kind of plastics that can be melted or that can be heat formed. So it's actually not like a very new thing, but it has been present in our history for like a long time. This, what you see is shellac, like the material that is made from, I think, the excrements of this little shellac. Now how it's called, the animal, like the tiny insect, and the excrements from like you made shellac with, that was, for example, used for records or like for different applications, and it's still used today for some things. Then later on, we got the first thermoset plastics, like plastics that once you can melt them, you can put them in shape, and then you cannot make them soft or liquid again. Like once they are produced, they are set forever. And those are were examples from the, I think it was, they started production around 1900, and then like the production kind of eased out shortly after the Second World War, with other types of plastic coming into the game. Yeah, some examples of the first thermoplastics, because when I'm talking about plastic today, also with regarding precious plastic, we're talking only about thermoplastics, so plastics that you can heat up again, so they get soft and melt, and you can like basically recycle them in the way that you treat them with heat, with temperature, high temperature. And one of these early discovered plastic is PVC, and I think it's kind of known that that's a very tricky plastic, because if you burn PVC, it releases, I think, chloride or chlorine, like a gas that is highly toxic. And it was for a long time used for tubing, and I think it is still partly today, or for windows. But at least is what I heard from people working in the plastic industry. They try to get rid of this plastic, but for some application, I think it's quite hard to get it out of the system. And then, like, this is just like a timeline that shows you like that actually the plastics we know today are quite a young invention. Like, it's mainly the industrial production mainly started after the Second World War, when just like the demand for a cheap material with like the economical acceleration started to rise. And here like the plastics that are maybe commonly known better are starting, I don't know if you see my mouse on the screen, but like the very last one, for example, is polypropylene. This is one of the most commonly used plastic, or polyethylene. And so like on this timeline, they are rather young plastics, you could say. And those are also the plastics type that we focus with precious plastic on, because they are not so toxic. Jumping into like the last part in this timeline, from like history of plastics to rather recent events, I just wanted to point out that plastics are kind of an ecological boomerang, because you throw it and then you don't see it for a long time. And this could be maybe said for example, like practices like Germany did for like decades, that they just exported their plastic waste to other countries' landfills, and then they eventually sent it to recycling facilities that did not even exist, and so they could get a certificate that they recycled the plastic, but in reality it landed on some landfills. So, and now, I mean, as I said, I'm not an expert, so this is just things that I collected from different sites together. And what I've know of is that this practice of shipping off plastic waste kind of stopped some years ago, and that's maybe also one of the reasons why like this topic of recycling is getting more and more current again, because now some solutions have to be found, because you cannot export the problem anymore. And with this idea, like precious plastic exists around for 10 years now, and the main idea is that you kind of go back in history where plastic was actually like a high-end application, like a niche product. And for precious plastic, for this network, or the people involved in this network, as the name says, plastic is something considered precious and too precious to throw away after a single use. So what you see here is like a kind of a big diamond that was produced some years ago in Eindhoven, where this precious plastic network met for the first time. And I think it was around 60 people came together from all around the world. And for an amount of 1 year, these 60 people developed the machineries, like open source machineries further, and like to show like the beauty also of plastic, they produced this, I think it's like a ½ meter big diamond shaped plastic stone, you could say, just to give like some visual that that could kind of stand for the beauty, or the aesthetic beauty of plastic. Okay, so from this kind of little bit historical, or like this timeline intro, I would like to go to like the plastic types that exist today. For me, it's now hard to ask you, because I hardly can see on this small screen, but I guess like normally when we talk to teachers or to children that we have in our workshop every week in Vienna, we always ask like if somebody can name like plastic types, and we are mainly like often happy if people can point out 1 or 2 plastic types. Like maybe people know PET from the PET bottle, and then often it already stops the knowledge about plastic types. So that's something I think it's kind of important to know. And of course there are hundreds or thousands of plastics, but the main ones are those, and like those are the mass-produced plastic that we use today in the plastic industry. The most known is probably PET, like from the bottles. Almost all bottles are made from PET. Then there's HDPE and LDPE. They are kind of little bit the same, only that one has like a higher density, the other a lower density. This is the HD, higher density and low density polyethylene. That's quite a big fraction of what is produced worldwide. Then there's polypropylene, PP. PVC, as I said, like the more kind of dangerous one, and then there's polystyrol, which is a little bit more brittle. But those are like the big plastic types. Then here you can see what type of plastic we use to work in a handcraft way. And that is mainly in the middle, the polyethylene and the polypropylene, because they have no softeners, like no additives that have like toxic, that are toxic. So we don't work with PVC, we don't work with polystyrol, because also polystyrene, sorry. Polystyrene has, like, if it gets hot, it can there can be some leach of styrene, which is like a dangerous gas that can evolve from melting polystyrene. So these are the two types that we work with: HDPE and PP, like LDPE also, but it's not so common. It's like mainly HDPE that you find. Good. And then, of course, that material that you probably also know of from 3D printing, PLA. So that also a plastic that we can work with in our workspace. Here you can see just the numbers of what plastic types and which amount are produced in 2021. It was. On the right side, I marked you the plastic types that we as Precious Plastic can work with, and you see it's actually quite a big amount that is like usable for us. And on the left side, you see like the small fraction of PET that we use in the production with the company that we just founded, Phantoplast. That's an overview of where plastic is used, and you see like more than 30% comes from packaging waste. Like not waste, but like packaging is produced with it that then ends up mainly as waste. And I say like packaging ends up at waste because it's still quite hard to recycle packaging waste, because you have stickers on it. It's maybe oily, so it needs a lot of washing and treatment in order to be recycled. So diving into, I think I skipped the slide. Yeah. So diving into the Precious Plastic Global Network. In the background, you see a map that I think I made a screenshot a year ago of. This is like a map showing the workspaces that exist globally. So if you go on the website preciousplastic.com, you will find this community map that was created by the network for people to find each other, basically. So we as a workspace in Vienna just made like a pinpoint, and we're saying, hey, we have a workspace, here are our contact information. If you want to get more knowledge, you can just contact us. But you can also see this hands on the screenshot of the map. And those are people that are interested in joining an initiative, and they would have like a general interest. So it's also for us to find people in our hometown where we want to start an initiative, in order to get a group together to start an initiative. So when I went to Vienna, I went to this map and I saw, hey, there is a guy called Florian on this map that also wants to start an initiative. And then we met each other, and then like some month later, we organized our first workspace, and we had like in the end a group of 4 people that started our local initiative. So this was actually a really great tool for us to find each other. the basic idea of precious plastic is to like really create like is a kind of a systematic approach, you could say, and it's more or less the same that you find in industry. Like you have like different companies that do different things. Like you have one company that is shredding the plastic, then the other one is then extruding it or is shaping it. And it's kind of the same idea, only on like a smaller level. So it's also, it could be used not only by big companies, by big players, but also by smaller initiatives, associations, smaller companies. And I think that's important, because if you think about your own like your friends, your network, probably like most of you know somebody that that is working with wood, with timber, with metal, like, because those are materials that had been around for quite a long time, and there's like a long-lasting like handcraft tradition with those materials. But if you think about, if you know somebody that works in like with or in the plastic industry, like I don't know anybody that works with plastic. And also if I ask around, maybe there's somebody who studied something like some plastic engineering, but it's really hard to get knowledge about plastic, because basically there is no handcraft tradition, or no cultural tradition about this material. And that's mainly, this is one of the motivations for us that we started this workspace, because we wanted to give basic education about a material that is all around us all the time, and hardly anybody knows something about the material. And it's also not accessible to work with plastics in a handcraft way. So if we talk about precious plastic workspaces, it's also important to say that there are many different versions of how plastic, like a plastic recycling workspace could look like. On the top right, you see this container that was built in the Netherlands a couple of years ago, where they wanted to show that like a recycling workspace could fit in as also a very small place, actually. So they did put this double container together and built like all this small scale machinery into the container. On the bottom right, I think you just see it's like an application. I think it's an extruder that can extrude like a plastic sausage, and I think it was used for some fair or festival, where they wanted to show that there are also mobile applications, or you can build like mobile applications to work with plastic. On the top left, you see our small team of Phantoplast, but there are also some people that come from Precious Plastic. And on the top left, it's a workspace, I think in Nigeria. And that's like a completely new story, because I think in a lot of parts of the world, there is simply no recycling industry. I mean, there's probably also no plastic industry, but plastic is such a global material. So this idea of precious plastic, to have like this holistic approach of all these steps, from granulating, shredding the material, like making it into small parts, and then like all the steps needed to have like a finished product. I think it's interesting also for these developing areas in the world where there's basically no industry around this material. Precious Plastic is organized, or like the communication part of this network is organized on a Discord channel with a lot of sub-channels, so you can find each other, like there are different groups, and you can see that there are actually quite a lot of members. I think the screenshot is already also quite old, like maybe 2 years old, and there were 25,000 people that were in this Discord group connected, and I think by now it's even more. So last time I checked, I think there were around 1,000 workspaces all around the world that were in one or the other way working. under the umbrella of Precious Plastic. And this is, now I go a little bit into the website, like the tools that are offered within the community. So basically there's a core team of, I think, around 5 people that kind of maintains the infrastructure that was built with this bigger group of people a couple of years ago. So like maybe just because this is something I didn't say, Precious Plastic comes from one person, like a Dutch product designer that came up with the idea of just basically making 5 machineries, small scale machines. And he put the plans to produce those machines online. And then from there, it was just growing, like more and more people got this, the blueprints to build the machines and rebuild them and send them feedback. And then a web designer joined this Dutch industrial designer and made him a website. And so it was slowly upscaling, and at a certain point they got a big funding, from a sustainability fund, and they could invite with this money 60 people to Eindhoven, and for the time of 1 year. And in this 1 year, the 60 people basically rebuilt all the machines that were already existing to a state where they could easily rebuild. Videos had been done, tutorials how to build these machines. And the whole infrastructure was created to build and also to sell and buy different tools, parts for machines on this website, preciousplastic.com. And this is just, that's the bazaar where you can buy or sell machines, molds for the machines to shape the plastic. You can buy materials that otherwise are really hard to be bought by like small initiatives. Like normally if you buy plastic or granulated recycled plastic also, you have to buy it in amounts of like 1 ton. And even then it's quite hard to find a recycler that sells you only 1 ton, but mainly it's like a business where you buy and sell like really big quantities. But on this bazaar, you can also start from like, I don't know, we also sell, for example, kilo-wise our shredded plastic. And you can also buy and sell products that are made with plastics. Then for inspiration, you can also check the Instagram side of Precious Plastic, where a lot of initiatives are introduced worldwide. I think we also once were featured there with Precious Plastic Vienna. And it's just really nice to see like the diversity of different workspaces that exist around the world. So the different workspaces have different machines. They are organized, some of them as associations, some are companies, some are just loose groups, some are artists, some are more into research. So it's really nice to get like an overview about the diversity of the network. How to build a workspace. So there are these machineries. And the first thing that you need to do is like find people and the workspace to run like an initiative. And here on the left, you see our workspace that is in the kind of in the center of Vienna, in a building or in an association called the WUK. That's like an autonomous association with around 600 members, and it's like a big house. A courtyard, and there are a lot of space for ateliers, for artists, there's a school, kindergarten. There is space for events, for concerts, and one of those spaces we got several years ago. And we were renovating the space, and now we have like several machines on around 60 square meters with a team of we're around 10 people with Precious Plastic. But as we are all full-time working or studying, it's like there's always a group of around about 3 or 5 people that are really active in our association, and the others like they help out if some more workforce is needed. If you want to start building your machineries, as I said, like there are these tutorial videos and the plans on the Precious Plastic website, and we also like basically started building our own machines several years ago. And then when you have the machines, you need to find actually local sources of plastic waste, and that was maybe the hardest part for us to start with, because of course you can collect your own trash that you produce, but that's, I mean, often it's impressive how much waste we produce, but then in the end it's not enough to really work with it. So we just started to were looking around and contacted companies, or actually also companies started to contact us if we want to take their trash. On the left side, you see like our bicycle with like a bicycle cargo thingy in the back, and we were started to collect these white buckets from a mushroom producer, like was used before for, I think milk was in the bags, then the milk bags, they got useless, and they were given to a producer of mushrooms, and then with coffee ground in the plastic buckets, they started to grow mushrooms. And then when that was done, they had like hundreds or thousands of white plastic buckets that were from polypropylene, and that were perfect for us to use because it was quite easy to clean those buckets. And on the right side, you see these pots from a cosmetic company, from Lush, that maybe some of you know. So they have this policy in the company that they try to find ways to recycle their plastic waste. And in the UK, where this company comes from, they have their own recycling factory, but as Austria is a quite small market for them, they were looking for some partner that would make use of their plastic pots, and they contacted us as an association. And so from time to time, we pick up bags of their black and transparent plastic pots, and they clean them for us by hand, so they're actually quite clean. And maybe like an interesting side fact, I said before that like packaging waste is quite a pain in the ass, because it's often oily and stinky, and you have a lot of stickers on packaging that is not the same material that the plastic it's like the packaging is made out of. But in this case, the sticker is the same material than the pot itself, so it makes it also easy for recycling. And that's maybe also often I heard that I think 70% of recycling is, or like the biggest part of recycling is actually in designing the product, and that's something where it gets really feasible, because if you make the sticker from paper, then it needs like an additional step to be recycled. So that's actually quite a clever solution to have just one material that the packaging is made of. Then after collecting the plastic, you kind of need to sort it if you want. You have to sort it by the types. So we sort by polypropylene, polyethylene. And if we find something that looks like PVC, then we really try to get rid of it, because that's the one that is quite dangerous to work with. And then sometimes we also sort the plastic waste by colors. So on the right, you see like thousands of white HDPE lids from bottles that we had to sort out for a job we were doing some years ago. And then when it's sorted, we shred it with like a small shredding machine. The one that we use is not as dangerously looking as the one that you see here. It's just to see like how it's actually mechanically done. And if it's shredded, you can start again to melt it and to work with it. So there are different techniques or different machineries. Like you can press it. Like on the left bottom, you have like a steel mold to produce sheet or board material with it. In the middle, you see an aluminium injection mold. That is, I think, a ruler that was made from it. Then on the right top, you see like a more like a free form melting technique, like from extruding, which is like basically the same, like and not the same, but it's similar to 3D printing techniques where you extrude like kind of filament. Yeah, and then you can also you use the material more like in a free way and like just melt it and get some mold and shape it around by hand. Also possible. And then with the, yeah, once it's melted, you can then again do different raw materials. So at Precious Plastic Vienna, we did a lot of this sheet and board materials that you can see on the right top that can look quite nice, like terrazzo, or sometimes like marble, and you can really make aesthetically appealing board material from it. It is quite robust and can be used indoor, outdoor. But you can also make beams with it, or you can also, again, make 3D printer filament if you have the right machines. Or use it for injection molding for like small series of injection molded parts. Yeah, just some products that were made in the community that you can also find on the bazaar on the Precious Plastic website. The material, like the sheet material, can be used very good as surface material, like for tables or for seating opportunities, but you can also work with it in a very artistic way or make jewelry out of it. So it really can look quite amazing. Also in combination with wood, like I really like this example of this combination of with wood and plastic. Okay, so what we do at Precious Plastic Vienna is, as I said, like this is just an overview of where we get our material from. So we get it from like companies like Lush. Then we have on the in the left middle, we get materials from labs, because there you can get really colorful material or waste, which is really hard to get. Like colors are quite hard to get a hand on, but that's also the material that is like the nicest to work with, just because it's colorful. And what you see, like these pipette holders, where like in the laboratory, there are a lot of these transparent little containers that are used for the experiments. And once this box is used, it's often when it goes to trash. Like there are also like circular systems, but in the laboratories that work mainly like as a business, not as a research institute, they just throw them away. And we get access to the containers, and we know which that they are safe to work with, and that's a good source for us to work with. Then we also have in Vienna an initiative called Stöpsel Sammeln, which is like a association that is collecting the tops, like the bottle tops. And we, from time to time, if we need more material, we can also just buy it from this initiative that then gives the money that that comes from us to like a social cause. I think they support children that have some diseases that have like quite high costs to treat them. And so it's also nice to see that there are initiatives to actually use plastic recycling for a good cause. Then we collect, we are like a hub. I think some of you maybe met these people from Prusa Research. I saw that they're in the program. And Prusa set up a map where you can pinpoint yourself as a precious plastic, or like in general, like a spot on the map that collects 3D print rests. And we are one of the initiatives that set a pinpoint in Vienna that you can bring your failed prints to us. So we collect PLA and PET-G in Vienna. And can then use it in our workspace for workshops, for small productions. And those are the machines that we have at our space. So we have a shredder on the top left. That's the most basic machine to get the plastic into small parts. Then we have an injection machine where you can kind of shoot liquid plastic into aluminum molds or in other types of molds and make like small, like a small series of the same object again and again. Then we also have a 3D printer that I'm not an expert in 3D printing, but there are some people in our association that are more into 3D printing, which I guess is more also your topic. Then we have a heat fan that can be used nicely to shape plastic, because you can get heat fans that you can temperature set, and then you know which temperature the melting point is, so you can set the heat fan to this temperature, and then you can really nicely shape also plastic in a free way. Then we use a pizza oven for the production of sheet material. So you have like a steel mold with a frame. We put the granulate into this frame and put it in the pizza oven. And then we put it into this cold press that you can also see on the bottom. So it's really low tech, but actually we have quite good results in our workspace with a lot of low tech machineries. And then you can also on the top right, you see like the equivalent to the pizza oven and the cold press. In one machine, it's like a hot press where you just with heat and pressure press material together. Yeah, that's maybe also one of the parts that is most interesting for you. So the biggest part of our time at Precious Plastic Vienna we use to organize workshops. We did already a lot, and I think I met already more than 1,000 kids in my Precious Plastic time. Every Friday we have workshops, because that's the day where it's easiest for us also to take a day off. Yeah, and later on we have another workshop with a school class. They just come to our workspace and they get like an introduction to the material, and then for 1 or 2 hours they can really produce something with their own hands, and that's like a very nice way to get kids and also the teachers often excited about material, and then you can really easily tell them a big story of how they can organize themselves to run a workspace, how they can get educated about the material. So by making it's just so much easier to to access the synapses of the kids and get them focused for 3 hours, which I myself never could when I was at school. So it's also for us also a very nice experiment or experience to work with school classes. Then I just jumped through some projects that we did with the organization, like with the Association Precious Plastic. Like this is an example of where we made sheet material and then applied it to one of these Grätzl-Oasen, these small islands in the city that you can find in the summer month in Vienna at many streets, where you just like have a temporary space that can be communally used by the neighbors. And yeah, we set up together with like an initiative, a small island where the plastic sheets were used to make seating and planting opportunities. Then we also did some, like to finance our activities at the association, we started to produce tabletops. This is like an example for a restaurant, coffee place at the Water Channel in Vienna, where we did 80 tabletops, which was our biggest project. And with the money we made from this project, we could like finance the association for more than a year. So that was a nice experience. Then we participated in the reconstruction of a park in Vienna, where they tried to use only recycled and used material to reconstruct an entire park area. And again, we used our sheet material to make little tables with it, with like on the left you see like a pin board, or the cover for a pin board where neighbors could pin like invitations, or when they lost their dog or something like this. Then those are just small objects that you can do with injection molding, like cups or spinners. In this case, we tried to, we were in contact with a company that actually produced a lot of waste, which was for us quite weird to, it was like a greenwashing project which in the end also didn't finish. But it's a company that makes these little blisters where they sell aroma drops to flavor your water, which is a quite strange thing actually. But we just tested their waste material to make like cup material with it. Then we were approached by some designers and architects to make like small interior design projects, and in this case I think it was a collaboration with this mineral water company Föstlauer, and they did this cube where you could kind of store a water I don't know, it's called a water box for the bottles. And basically you can just also to know you can work with plastic like you do with wood, more or less. You can cut it with wood, like with sawing machines. You can drill it. You can CNC cut it. You can saw cut it. So it's actually a quite nice material to shape, and so you can use also all the machineries that you use for to treat wood. To shape and put plastic into shape. And then with this experience from that we did with precious plastic, and that we got approached by more often by other companies, especially architecture companies. We started to look for the opportunity to find a company, and in the end, like 1 year ago, we started to we got a funding from a national funding institution, and these 5 people that you can see, that 3 of them were also already part of Precious Plastic. We founded the company Fantoplast Circular Design. And since January, we started like a production place in Vienna Seestadt, this new development area outside Vienna. And in this building that you see in the left, we have like not one floor, but one bigger room where we set up a workspace, a little bit similar that the one that we had with Precious Plastic, but just a little bit bigger size. So we have like a big heat press and a big cold press to cold the sheets. And we became a producer of recycled board material that can then be used again in very different ways in design and architecture. Yeah, and here you see just like our first collection that we did. And you see like the size of it is like more than 2 meters by 1 meter, the boards that we do now. And so this is kind of the business side of what came out of Precious Plastic, and the Precious Plastic initiative in Vienna still exists and is run by the same team. So we kind of split up from time to time and have this educational part of the initiative and the more economically driven part, which is the company. Yeah, thank you. And I think I'm curious if you have questions. I don't know how you technically do it, but I'm really happy also to answer questions.
Thank you, Rafael. Can you hear me? Yes, I think. No. Can you hear me now?
Yes, I can hear you. Yeah.
Okay, perfect. So do we have any questions? Yeah. So we have a question directly from Prussia to you.
So good morning. My name is Jiří Prusha from Prusha Research, and I would like to thank you for your presentation. And yesterday we have the opportunity to visit the STEAM lab here at the JKU, and we also seen that they are collecting the PLA plastic from the bed prints. And I would like to ask you if you could put some example what you are doing exactly from this PLA plastic from the 3D printing from here, and if you are also planning to make some tracing. That's for example, that the picking up places such as STEAM lab here could see what will be happen with this waste in the future. Thank you.
We are collecting both PLA and PETG.
Yeah. Yeah. So with the PETG is really easy to work with because we will give it to Fantoplast, to the company, because all the sheet material that we produce on a bigger scale are made from PETG, because it's a very nice material to work with. And the PLA we mostly use or we make again filaments with like this filler maker machine that we have, or we use it also for injection molding, which like for the workshops with the school classes, which is a little bit harder to injection mold it, but it also works quite well. And the nice thing about PLA, I think, is that you can polish it and you can sand it and you can make really nice refined objects with it. I hope I answered all your questions, because I think it was more than one question.
Yes. Do we have any other questions? Yeah.
Hello, thank you for the interesting presentations. I would like to know, because I'm wondering if Precious Plastic has some kind of learning materials that teachers or school can use it, because I believe that raising awareness for using, reusing and recycling plastic would be introduced to school as earlier as possible. Thank you.
I think there's no precise material made for schools or for like presentations, but there are so many interesting videos on the YouTube channel. So actually, before I made this presentation, I was thinking to just show you different videos that I collected, because you get such an inside perspective of this whole network that is run by a lot of amazing people. And there you find a lot of, especially video material, about how to make machines, but also like interviews of the different people that participate in a network. You can also get like really this fields perspective from members of Precious Plastic that visit other members like in all around the world and show what people all around the world do by recycling plastic. So there's a lot of material that you can find online.
Great, thank you. Any other questions? Yeah.
Well, thank you so much for your nice presentation. I was really interested on how you started connecting your project and the culture and the history and so many things like that. So my question is, are you thinking of opening some rooms for more cultural stories to come to your project? Like from different people, how are they connected with whatever the plastic that you are doing?
I mean, as we are like an open workspace. So I mean, at the moment we have like, because we're really running on our limits, because just time wise, because we are all full-time working. But if we are very open for people that reach out to us, that want to organize something around plastic, or that's we can host people, we can organize events together, and so we are also open to go into this direction if we are approached by somebody that is interested in this type of topic.
Great. I think I have a question if no one else have one. How if I want to get, let's say I'm a teacher here and I want to get my group into your workshops, how can I do it? How can I go there?
Yeah, you just write us an email and then we find together a nice Friday when both of us have time, or also another date if it somehow fits in. We normally have like costs for 3 hours around 200 to 300 euros. That covers the cost for rent and the material, and also to get like, we always two people of the association that is leading the workshop, and each member gets like a small share, so just to compensate for the time. And mainly the schools do it by having some type of like program in the back that is financing those workshops. And
Okay.
if there are school classes that are not financially capable of raising this money, then we also to try to find ways that it's cheaper and that it somehow works.
Great. Okay, great to know. Thank you. If we don't have any more questions, just thank you very much, Rafael, for your time, and we will definitely visit you soon.
Okay, yeah, just reach out. Happy to host you in Vienna.
Yeah, thank you.
Okay.
Okay, Ceci, what do we start now?
Okay. All of you have your tickets ready? Someone needs some tickets for some action? Okay. I will be here just to give you. And we are doing the reference now.
Okay, now
Yes,
good.
it's okay.
We are names for the for the printer.
And Cruzala. Excellent.
Yeah, senin ben çok kopya.
Yes, I can. What is it?
I'm not sure. I can take.
Hola,
Hola Matías,
¿cómo estás?
muy bien,
Estamos.
estamos.
¿Cómo están?
Hola.
Saludos.
Estamos ahora tuvimos la primera presentación.
Estuvimos viéndola. Sí.
Bien, tuvimos unos minutitos de corte y vamos a sortear la impresora.
Lo hemos escuchado en YouTube y estábamos aquí pensando qué lástima no poder estar allí en el parte de participar.
Sí. Y nada, y después arrancamos con las presentaciones. Yo no me acuerdo en qué orden están ustedes, creo que están medio al final, ¿no?
En los
Sí.
penúltimos, sí, correcto.
Da,
Era para
entonces,
comprobar como en las indicaciones nos comentabas que la mejor opción era estar conectados y ya en el momento
como
les
quieran,
vamos a
igual
compartir.
si quieren conectar, igual si quieren quedar conectados es lo mismo, pero si no, se conectan un ratito. Pero
Perfecto, pues lo dejamos aquí en silencio y sin vídeo y nosotros le seguimos aquí felices.
muy bien, bueno,
Pues hasta dentro de
bienvenidos.
un rato. Que vaya bien el sorteo y suerte para todos.
Gracias.
Esperando por nosotros.
No.
Oh, yes, sorry, if you have a presentation today in the afternoon, I will give you 2 tickets.
Oh, I have one.
Okay. If you have a presentation today, I need to give you 2 tickets. 2 for you. Do you want your tickets? No, it's okay. Someone else has presentation today? You? The pink there is a disaster. Yes? You are presenting today? No, just to be here. It's one. It's one and one. Oh, yes, I'm sorry. I wrote you. Just checking you. The banner is true.
And also the.
Okay, yeah, I saw it. You're welcome. I want a picture with the people putting alone. Or secretary. Okay, we are ready? Selene, are you ready? Yes. No, if it's not here, no, it's not. No. Okay. All of you put your tickets here? Yes? Okay. I will take some pictures. Yes, of course. Okay, we are ready to wait that the people. Yes, please. Shiri maybe can take one. Shiri. Oh, perfect. Oh, last minute. Perfect. Okay. I don't want to guess. Okay, we are ready. Yes. Okay. More?
And there are no tickets for presentation. And there are no tickets for presentation.
Yes, says he was giving it up now.
Yes, for presentation.
Yes, I offer and you didn't say anything.
You never.
Okay, wait.
You should keep.
Okay,
Yeah.
come on, really fast. I offer and you didn't say anything.
I don't wanna. Yeah.
Okay, the important moment.
Quiz.
Short is shuffling.
Okay, so this
She will get one.
okay.
Wait, because we have one more. Wahid, take some pictures. Okay, shuffle again. So thank you.
I think
for
we should
collecting
go-
tickets.
We should go live on Instagram too.
Oh, yes, great. I like the idea. Put your tickets here, yeah. Come in. Your tickets. Come on. Come on, Angelica. We are waiting for you. Oh, she needs to put the name. We are using Prusa filament box. Okay. Okay, because you are working in the same place, so it's okay.
Here, my video.
But if I put, just put at least an A, really fast. Come on. Dale la lapicera, Angélica, por favor. Eso. The Turkish team is really excited. It's only one prize. Okay, random. Okay, next time.
Okay.
Okay, we are ready?
If you don't win, you can buy a machine with 15% discount.
Don't forget it. Okay, ready? So please.
So the most amazing moment.
Photo this
Do you want just easy draw?
change with
What's the
the
most dramatic
banner?
part?
Yes.
Grammatical, of course.
The most dramatic part, yeah. So I will add 2 rules, yeah.
Okay, 2 rules. Okay.
New rules, yeah. The first rule is that the winner must be presented here now.
Okay.
And in order to make a little bit more dramatically, I will choose 5 tickets now.
Okay.
Read the names, and after that, we will choose from these 5 the winner.
Okay, perfect. I like it.
The first one, second one,
Mix more.
mix more.
Yeah, like.
Now it's time for the math class. So I can do the calculations and we can discuss it, no?
I don't think so.
Mix that. And the last. From the bottom, yeah.
Okay.
I will, sorry, because people probably are not hearing you online, so now.
Only white tickets?
Only buy tickets. So, and now, I will read the names, yeah.
Okay.
It's, we will have a chance now. It's Monica.
Monica is there?
Oh, Monica is there. Gertrude.
Gertrude?
Kusish.
Maybe? Kusish? Yeah.
Kubra. And Eva.
Which Eva? Maybe another Eva?
Eva Maria.
But she's not here.
She's not here.
No, Maria is still here, so remove and another one. Yes, me too. She has only one ticket. Yes. Yes, for a workshop.
It's right.
And now?
You have another box.
No, but I can remove this one. Safety. Okay, we have 5 here. Good luck.
And the winner is Kusish.
Congratulations.
So, congratulations. That's Kusish.
There is another rule in the competition. Yeah, the printer is yours,
Yeah.
but we know what is the last rule for the competition. So it's the kit. So you have to assemble it.
Thank you. Right, congratulations. Thank you everyone to take part of this. Thank you. Okay, and now we need to,
Really happy that is going.
yes, do you have a space in your luggage? Or you need to manage it? Okay. Okay, thank you again, everyone.
Separate the printer in more luggage.
Yeah.
Yes, yes, we have some tips.
We can help you.
Thank you, Prusa, again for the present for our participants. I hope you enjoy the experience. And now we are coming back to the conference. So, Michelle?
Michal.
Sorry, Michal. We lead with Musa this part.
Yours?
Thank you.
So we are doing 3 presentations, then we have a coffee break, and then we are doing again. Okay?
Thank you. Okay, thank you everyone for being here. So Michael and I myself will be here to lead this session. So we have only 2 things that are very crucial. One, we wish you a nice presentation and nice participation. Second, we'll be here to observe the rules of the conference, and we are going to be very strict, especially with the time. So for you not to be disappointed when you're here, Michael will remind you some of the rules. My name is Musa.
So rules are same as yesterday and day before. You have 15 minutes for presentation. We will show you 3 minutes before ending. And then will be 5 minutes for some discussion and questions. So we can start with first presentation with Milke, with topic of AR supported 3D modeling, innovations in mathematics, education through ChatGPT assisted 3D printing creation. So it's yours.
Ich mach schon.
Don't worry, take your time.
Do you have it online? Do you want to open online computer? Yeah. If you share the link, I can open it.
Okay.
Stop sharing your screen. Some technical difficulties we are solving for the online video.
We are going to break soon. We have little difficulties.
Sure. No? Sorry.
Yes, but. Hello again. But. You cannot see it. But the voice again reflects.
Sorry. You can just speak and everyone, you have the microphone on, so it's. Through your mic, your voice is through your microphone.
Okay, but this.
You don't need to do anything in the computer, just pass the slides.
Okay, okay now. Actually, I prepare for via AI, but we now the problem. But okay, I'm Melike. I prepare this presentation with my advisor and father, and he is an associate professor at Hacettepe University, and we work together about artificial intelligence, and this presentation about artificial intelligence supported 3D modeling and innovation in mathematics education through ChatGPT assistant 3D printing creation. And he says the good luck presentation, Melike, but and mathematics is crucial for developing conceptual understanding and problem-solving skills. Yet it is often perceived as challenging by students. 3D printing offers scientific tools to overcome this challenge by enabling students to visualize and physically interact with mathematical concepts and objects. However, to exploit the educational potential of this technology, teachers and educators need access to high quality introductional materials that are easily customizable. And ChatGPT addresses the need by assistant teachers and educators in creating customized 3D printing models for mathematics lessons. And this resource details how ChatGPT can be utilized, outlining the steps involved in the development and implementation of teaching materials. This resource explores the integration of artificial intelligence and 3D printing technologies into math education, with a focus on leveraging ChatGPT to generate introductional materials into the form of STL files. And inside the ChatGPT-4, there is a list of tools that specifically lean towards generating STL. I used to there for this study, and we know that it will respond according to background created by the person who create this tool. So if we ask some prompts to other tools here, they may answer in different styles. First of all, the question we wondered was, can we create an STL file with ChatGPT? We asked to create a cube without any dimension, and it creates, and it determines this dimension. And I asked it to create a cube by sizing it, and it was able to that. We determined 666 and it's great. And then we wondered if we only needed to give the information about 3 sides to form a rectangular prism. And this way we understand the values correspond to the X, A, and Z axis. And we also tried to ask the question in different ways, and it created this file. And this time we asked to create 2 different shapes and position them, and it did it too. And geometric shapes were also created in this way. Then we wanted to create a daily life object, and it actually created in the shapes of the table, but the table was upside down. Then we entered the prompt again. We make it in a normal table view. Yes, it also creates this, but we realized it's actually creates the STL to make the desired design for ideal printing, and this is a good thing actually. And at the end of the process, we came to the conclusion that when we write the prompt, we are actually writing a mathematical definition. And it can be concluded that it is important to recognize geometric solids, determine their position, and describe its value. Students improve their mathematical and language skills by describing geometric solid in detail, while principle of prompt engineering enhance their spatial awareness and visual thinking. Discuss mathematical concepts depends their understanding of theories and applications, showcase practical application of prompt engineering. And that is. Thank you for your attention.
Okay, now it's time for questions. Do you have some questions?
Sorry.
I can ask you later.
So the GPT, sorry, I missed some parts, but the GPT that you are using, the specific one, it's something you created, it's already there to use. I can go and use it. It's if I have the paid version of ChatGPT,
No, this pro version.
yes, I have the pro version, so I can use that one.
Yes, and first I research. I write STL and I search and I select another one.
Okay.
And I create this for this presentation. But actually, I tried another tools and their tools another answer the our prompt, because we want to generate a cube. Okay, this one it create a cube and it describe how this do it. But another tools not describe, just give us files.
Yeah.
But specifically, I think there is a use to Python code, because both give a STL file and a Python code.
Great, thank you. I will try it. Sorry.
Go ahead.
Thank you, Malika. It was interesting presentation. I'm wondering if it is the free ChatGPT 3.5
No.
or the 4.
What?
Which
No.
which version of ChatGPT?
4. Because
Subscriptions.
yes, because this normal ChatGPT not create this STL.
So that's my question. How if the one who do not subscribe ChatGPT, because I try with the free one, it does not generate any files. Thank you.
Yes.
Any other question?
No.
Well, so I have a favor to ask one. So I would like to know, like, in your experience, what are the set of skills that you think somebody should have to be able to use that one to generate those models?
Our experience.
Yeah.
Actually, I like this process because we create a table and we write the shapes, cylinders and prism, and this no, sorry. Okay, this creates this, and I don't know why. Actually, we think this wrong create, and then we again prompt this table, but again we realize actually this ideal printing process, because we printing for firstly we I don't know, then yes, and then create, and this actually really good things for us. And actually I am trying another mostly we no whole create actually, but we try actually we improve our prompt process, then we there would create STL files.
Okay.
Okay.
Thank you. Very interesting. Is it possible to create more complex design? Just like in engineering, we have complex design. It's like frame or engine block, or is it possible to create it or just a simple form?
Simple form.
It's simple.
You say
design.
it's create the complex shapes. Actually, I tried the Escher model and step by step we prompt And yes, it's great, but sometimes maybe I need the more give a detailed prompt. If you give a detailed prompt, yes, it's great. Actually, I don't know, maybe other step we tried our assistants, our printing assistants, because this impossible and maybe we cried.
Thank you.
Yeah, right. Yeah.
Okay, we can continue with second presentation with Henrik. And topic making manipulatives in mathematics education. What is yours?
Share the screen and. Let me see how to share the screen. Sorry.
Works? Okay. Hello, everybody. I'm going to present my PhD project, and that's also a collaborative project together with Susanne, who's also the digital fabrication expert. But we are trying to see how teachers can use digital fabrication for making manipulatives. So this is what I'm going to talk about. I have a background. Oh, it's an old picture, by the way. I have a background as a mathematics teacher and a physics teacher. And since 2018, I have worked as a teacher educator, and I started on my PhD in 2021. So hopefully I will submit my thesis and defend them soon. Work in Norway, and we have 3 faculties at Østfold University College. We have a computer science where Susanne works, and I work at the teacher education faculty. And this project started because I have used manipulatives in my teaching. And I had this, I saw this manipulative that could reify the ratio between the volume of a cube and the volume of a pyramid with the same side length. And I've seen it made by paper, and I saw it in wood. But then I thought about, okay, but I won't do that. And Susanne said, maybe we could 3D printing it. And we did that, and that's how I started thinking about, could we use digital fabrication for making manipulatives? So we applied for a project about inquiring into how this could be made. So the objective with this project is to explore how digital fabrication can be utilized by teachers, and both pre-service and in-service teachers, to create manipulatives using digital fabrication. But we also knew that none of the teachers that I know about anyway had any experience from digital fabrication. So we have to take this in a 2-step process. First of all, we wanted to know how we could introduce digital fabrication for teachers. And the second bullet point is that we wanted to explore, okay, what are teachers reflected on digital fabrication for making manipulatives? And I'm going to talk about the first bullet point here, because 15 minutes is quite not so much time. And by digital fabrication, I talk about not just only 3D printing, but we also used a laser cutter, and we introduced vinyl cutters for the teachers. So 3D printing, and of course we had a Prusa, and that's only a part of our project. We we had 2 workshop series. We had first a small one with pre-service teachers from the 4th year in their 5-year education. And we had 4 half-day workshop where we tried to learn how we could introduce digital fabrication for pre-service teachers. And that was to prepare for our bigger intervention with 8 full-day workshops, and that lasted over a year. And it was important for us to have those 8 workshops because we needed a lot of time. But at the same time, we also wanted these teachers to have time between the workshops, so they actually made something in the workshop that they can bring back to the classes and use what they have made in the classroom, because we also saw that it was really important to really reify what they've done and make something with the students. It's lots different just to make something and not try it in practice. A video recorded all the workshops, had interviews with them before and after. We also have focus groups interviews during the workshops. I used community of inquiry as a theoretical framework, as an overarching theoretical framework. And it's based on community of practice, but it focused more on inquiry, and inquiry is really inherent in everything we did. And that's Barbara Jaworski, who's the first one who wrote about the community of inquiry. And she see inquiry in 3 layers, which we also adapted, but we want to inquire, we as teacher educator want to inquire into how we can introduce digital fabrication for teachers. But the teachers, they were inquiring into how can we use digital fabrication? How can we plan? Because we didn't know exactly which manipulatives they should make, but it was up to them to actually explore how they can use this for the students. And I have not focused on the students, but in community inquiry framework, also students work in inquiry-based teaching or learning with the manipulatives, but I didn't do that. I did not have the resources to do that. That's the next project. And we start to think, okay, how can we now introduce digital fabrication? And we had, from the literature, we tried to search, and we didn't really know how to do it, but we had some bullet points that we saw that it should be a hands-on experience that should actually do something was important for us. We wanted them they should use it in the classroom as well. So that was also important. And then we saw that we could first have introduced digital fabrication in a non-mathematical didactical context, but we saw that it should be integrated. And therefore, we also saw that it was really complex. I mean, they should learn digital fabrication. They should think about how they could use the manipulatives in a classroom with inquiry-based teaching and so on. So it was a complex endeavor, and we wanted to reduce the complexity. So that's we started to develop a framework for this introduction, and we developed this what we called a find, adapt, and create and share framework. And it's disseminated in 2 articles as well, because we started with the teacher could find, and lots of you talked about finding what's already out there, and there are many good manipulatives that are made, and lots of bad as well. So, but anyhow, we started to that it could find something that would need for their teaching, downloading and learn how to 3D print as in the process of just what they have found, and then they could plan, okay, how could I use this in the classroom? But from that, they could see, okay, we need to adapt it and somehow change something or make smaller changes. So that's a bit more complex. And the last and most complex part of the framework is to create something from scratch. And we also have this share that's inherent in the framework, because part of the maker community is to share something back to the community, or just to share with someone else. That's also important for the framework. And what we could see from the workshops, that there are lots of things that they could use. So they really saw that this find was a good resource for them, and they had no idea about it before. But also they had language issues, because we're from Norway, and the teacher did not know about the mathematical concepts in English. So we had to prepare them for that. We saw that the differing quality, so the teacher really need to reflect on how can they use the manipulatives, and they really also looked at the printing time was important for them, and sometimes they did not choose a manipulative because it took too long to print, or they made it smaller than they actually wanted. So that was also something that we saw from our workshops. And then we had this adapting the manipulatives. They could adapt it by using other tools. Perhaps they started with the 3D printing something, but then they saw there were other possibilities. Using a laser cutter, they could make it bigger, or they could add something, and so on. And one thing that we saw was that when adapting the pre-service teachers, they were more technology focused. They forgot about what the students should learn in the end using the manipulatives, but the teacher were a lot more focused. Okay, we adapt this manipulative just so it could improve student learning. So it was important to have this. Never forget, why are we doing this? And that could easily happen with the pre-service teachers, because they thought they were really into the modeling and that thing. And then the creating manipulatives. One teacher said that she could not have started from scratch creating a manipulative without having any idea about what tools are out there, what are the possibilities, and what are the constraints as well. But after a while, they started to become very creative, and they made some manipulatives that I have not seen anyway. Of course, you have the 100 frames on, that's really a copy from something else, but they started to make new manipulatives. They work really close together. They took one teacher started to do something, and the other teachers copy and develop something further. So it started to become a creative process in the workshops. And we saw also that the workshops were really important, because it took time. We had eight workshops. And then the sharing part was low threshold to share with each other, but we really have to prompt them to share back to Thingiverse, for example, because they said the teacher said that it was not good enough, and they didn't
didn't always feel that it was that they just wanted to collect things, not to share them back. But so that's something we have to work more on. And this is, of course, just the start. So we are planning now to continue with this project and see how digital fabrication can be a part of our teacher education curriculum. And we have started a collaboration with the Goethe University, and hopefully someone else want to be a part of it, and we would love to cooperate with all of you who have seen so many interesting things here today. And what I really missed is see how the children use the manipulatives, because that was not a part. We know quite a lot about manipulatives, and there's a lot of research about that, but what is happening with the children in the classroom, that's something I really missed. But you can't do it all, I think, at the same time anyway. Yes, there's a reference, and thank you for listening.
Okay, so now it's time for questions.
Thank you for your nice presentation. I wondered that what do you mean with fabrication? Yeah, the differences between printing and publication. Did it affect the choice of your manipulatives? Yeah, I wonder those issues.
I'm not sure exactly what you mean. I mean, they made we had no pre-assumption on what the teachers should make. They should take what they needed for their teaching and use digital fabrication tools like 3D printing and so on to make manipulatives to take back to their schools. But some of the manipulatives they made were really close to what you actually can buy. But so there are, I'm not sure what you mean. Perhaps, yeah, please give it back.
Fabrication, yeah. Should the manipulatives be so ideal for publication, or I can't imagine how the manipulatives should be for fabrication. Is it the same with printing? No, I couldn't. Yeah. What do you mean with fabrication?
Yeah. Okay. No. Yeah. If that's what you mean, so digital fabrication is the umbrella term for like 3D printing, laser cutters, vinyl cutters. So 3D printing is part of digital fabrication.
Okay, thank you.
Okay, sorry, I should clarify that from the beginning. So yeah, thanks for letting me clarify that.
Hi, thank you very much for nice presentation. And I'm not sure whether it's you haven't answered my question, but you work with pre-service teachers and in-service teachers. You had workshops for that, and were you working with them as two separate groups, or you have mixture of pre-service and in-service teachers in one group?
No, I started with a pre-service teacher workshop, and then that was more of a kind of a pilot study. So we could learn, okay, how can we actually introduce this, and what's happening when we're introducing digital fabrication for them. And then we had this larger workshop over 1 year with in-service teachers. And there was more of a practical reasons, because I got funding for the teachers, and I could not afford to have first a pilot study with the teachers and then the large workshop series. So that's why I tried with the pre-service teachers. Yeah.
Some other question?
Thank you for your presentation. It's it's not a question, but for example, it's suggestions in the line at younger size. And I don't know, it is your reality at Norwich, but in Portugal, in the pre-service teachers, in the last year, they are in the schools, and the teachers receive these students. It is possible to work with that teachers that receive the students and work also with the students to make
Yeah, if they should work together with this.
Yes. I don't know the reality in Norwich, but if in Portugal we have the pre-service, the last year are in the schools with their teachers.
Yeah.
But the teachers receive them, they know how to teach, and they have also classes with the students. And perhaps this is the moment with all together.
Yeah, yeah, and I think so for this, when we develop a curriculum for pre-service in our teacher education, but for this research project, I think would be a bit too messy to mix it up and see what does. But for future work, of course.
Because the realities from each one is very different.
Yeah.
They can understand what the needs for the students, and then after that they can do something.
Yeah, and that's. I think we will probably work like that. If we have this in the teacher education, if we incorporate the digital fabrication in teacher education, then I hope for a collaboration with pre-service teacher and in-service teacher with digital fabrication. Yeah. I don't know. Do you want to comment something? No. Okay. No.
I have one. I know the next presenter actually, and I will present something very close to yours. I'm wondering if in these workshops, I think especially with the pre-service teachers, are you giving some like didactical point of view on manipulatives? You are giving some, feeding them some research or something like that?
Yes, we did. Both in the pre-service teacher and in-service teacher workshop, because especially we saw this, that the pre-service teacher did, I think it was in their curricula before, so they should have known about manipulatives and so on, but we saw that they did not have. So we had also input about manipulatives, how to work with them, how they, I shouldn't say should look, but what could be problems using manipulatives. I mean, they are not inherently good in some sense. I mean, they have to be used in a good way to actually that the student should benefit from it. So yes, we had also input, didactical input in the workshops. Yes.
Okay, and the second one, it's I forgot the second one. Sorry. But when they create, they only need to create the manipulatives, but they don't create something like a guide for other people to use it or something like that.
Yes, they had to. We were really explicit that both the pre-service teacher and in-service teachers should make a lesson plan for how to use the manipulatives. Of course, the pre-service teacher did not have real pupils to test it on. Yeah. But for one workshop, we had a role play where we other play pupils because we saw that was really important for them, because it's one thing to make something that looks fancy, but okay, how should you actually use this, and what is happening when you use this? So yes, we had this, and that's yeah, we try to be very explicit about that they should be how they should use the manipulatives.
Thank you.
Okay, thank you. Now we can move to different presentation by Matthias, and it's on topic enhancing per-service teachers' knowledge through 3D MP task design.
I need to be aware that I'm also the camera operator. No, but I'm here. Hi, Diego. Just 1 second. Okay, so you're in an echo or no? Okay. No, okay. Okay, so my presentation is very close to what Henry did just now. I'm sorry, it's just in the initial stage, so I won't have too much to show. So I want to just share a few ideas we are developing here. And let me just move a little bit with this. So I'm starting from this tool. So 3D modeling and printing, I've been playing with it for a long time. I'm a math teacher. I'm a teacher for like 12 years now. I teach high school and university. And I start playing with 3D printers in my house, like making small toys and things like that. That's a good way to start. Now you have one. And I realized that there's a lot of potential in that for taking to the class. So I start reading about it, just playing with my students, and end up here because Schultz saw the things I was doing, and I came here to do the PhD. So there's a lot of possibilities in 3D printing. I'm sure you all know it. We saw it during 3 days, but there is at least I looked for it and I didn't find much research on the knowledge of the teachers if they use this technology. So I'm trying to see if we can enhance the knowledge of the teachers through this. So that's the title, and I'm trying to work on it. So because of that, when I came, Eva already had going a course on 3D modeling and printing for pre-service teachers. And I started to, at the beginning, help Eva, and then a few semesters, I took over the course and started changing some things. So we are exploring the possibilities. And one of the 2 courses end up changing into this material and lesson development, because we discovered that most of the teachers has the barrier of not having printers in the school. So it was like, yes, it's very nice, but I don't have a printer in the school. So, and I say, okay, we don't have money to give them printers. We didn't have at that time, now we have, but we didn't have money to give them printers, but we had some printers. So maybe they can create materials here and then take to the school. And that's a good way to use 3D printing if you don't have the resources. So we start moving on that direction. So of course, we are taking this design-based research approach to develop the course. We are, I think Eva knows better than me when the course started, but it's probably 2 years. Maybe even more. But so we have a lot of experience with the course, and it's evolving. But we want to now. My goal is to make it evolve into this direction and doing research into that. So really improving the course based on that. So you know about the science-based research. I'm not going to bore you, but there's a few cycles. We are planning the course, evaluating, going back, planning again, and just getting some insights from this process. And for this part, or sorry, okay, but that's the question I'm asking now for this moment. So after doing the course, the students need to create a lesson plan using the 3D printers. I'm just focusing now in the students that are taking the second course that is more on creating materials and manipulatives and different games and things. So I want to see which knowledge is mobilized by the student teachers through this design and fabrication of the materials. For that, I need to, of course, pick a framework to look at this. And there's a lot of options out there. And for some reason, this catch my eye. I think it's a very comprehensive framework to look at this. And it's not related with what happened in the classroom because I don't have access to the classroom either. So I can see the teachers, I can see what they plan, but I don't have access to what's happening next. So this provides a very interesting framework to look at the details. So I'm not going to go into details with this because it will take a lot, but it's kind of evolving from TPACK and combining other things into that. So I'm mostly looking at this, the teaching and learning and technology knowledge. So it would be the intersection of these three things and the mathematics and technology knowledge. For me, it's I'm a math teacher, but I'm really into the heavy math. So I'm really looking at what's happening in the intersection with math and technology. For example, before coming here, I was looking at GeoGebra and how the representational fluency and how the mathematical fidelity and things like very specific into the mathematics and technology. So this was very nice for me. And of course, integrates the teacher beliefs, the curriculum, and some other things. Just so we are introducing these different models or things. There's I know there's the Germans have a very nice word for something I like. It's the Grundvorstellungen or something like that. So the basic mental ideas, and we are introducing some like specific concepts to them so they can analyze what they are doing. And then after using that, and of course, everything else they learn in the training, they are creating these lesson plans. And then my thing basically now is analyzing the lesson plans through these lenses. So that's what I'm doing right now. So we have a lot of lesson plans, so a lot of work, but I'm trying to focus on that. And I'm going these are just screenshots from their lesson plans. So to see the first stage I'm in it now, it's like trying to see what they plan and, okay, it's connected to this specific knowledge. For example, this mathematics knowledge and the connection between the mathematics and the technology knowledge. This is very interesting because they were like analyzing the affordances of these stamps. The student creates these stamps for, she made a game and the kids need to stamp the functions there. So it's also connected with yours. And she was very concerned in her lesson plan about the fidelity of the mathematical object. And she was very explicit about it. So there's a very interesting knowledge I want to, or maybe the course, I think the course is putting the focus there, and I want to do that. And the idea is that after looking at all the lesson plans and start looking at these small pieces of what they are taking in account to do this, I will be able to just modify and tailor the course to be more precise into the aspects I want to focus. For example, this is something I didn't say anything about it, but they use it for planning. And it appears in all the or most of the lesson plans. So probably this is something I want to look at in the course, or at least have it there, knowing that it exists, because it's part of their knowledge, and it's important for me to consider. And of course, the technology affordances, and there's a lot of items I'm still analyzing. You will read soon from that. And I think for now, that's all about this specific project. Thank you.
Yep.
Okay.
Thank you for your presentation.
Yeah.
Do you have some questions, notes, something?
Thank you, Matthias. It's very helpful to reflect because I'm, as a teacher educator, thinking in a similar way. But what we do in the UK or in King's College is that the students create the lesson plan, then they teach it and reflect on it. Are you bringing that aspect in as well?
I would love to do that, but no, because not all of the students has the possibility of teaching it. But now we are moving into the in-service teachers because we had this project, so we had contact with the schools, we had printers in the schools. So probably our next step will be doing something like a workshop for in-service teachers and looking at the actual things happening in the classroom. Yes.
Yeah, thank you very much.
Thank you.
Some other question? Yes, it was really interesting to hear about your project. I'm just wondering about how did the students, the pre-service teacher, choose the manipulatives?
We first play with some manipulatives we have here. So they first get an idea of some possibilities, like games or some very basic things. And then we send it to explore the platforms like Printable, Thingiverse, yes. And they just need to come up with an idea, present the idea. The other students give feedback, and then they choose one topic. Yeah, that's like the process of doing it. I would say that most of them really like fractions. I don't know if it's easy or it's something they were discussing in another course. I don't know. But fractions is the most popular one.
So okay. You have some other question? No? Okay.
Eva, you know the answer.
Well, we could ask one of the teachers because we have specimen here from that course. If we wanted to afterwards, maybe. But in general, I also mentioned a lot of principles that they use and that they learned about pedagogical principles in their descriptions. So that's a good idea to look for them. I didn't think about, of course, because I'm not a teacher, I don't even maybe recognize that, but we should do that. Good idea.
Okay, so thank you again.
Thank you.
And now we have 10 minutes coffee break, and then we will continue.
I have to go with this to the.
Good idea.
So then, yeah, for the we need it, right? I got
Okay here. Is it okay here?
Yeah. Okay. We can continue with the presentation. The use of 3D printing in visualization mathematics classroom, a systematic literature review by Musa.
Well, good morning, everyone. So like you can see, this is our project, and that is the team that is involved in this project. So basically, we were doing a literature review to see how 3D printing is used in visualization in mathematics classroom. So yeah, what's wrong? Maybe you should sit there. Well, so the accessibility of the technology motivate educators to start using that technology. And once that motivation comes, then it prompts initiatives to enhance such technology. And this is what is happening with 3D printing, that once it became accessible, then teachers and educators were motivated to integrate it into the classroom. And that integration has led to these initiatives. And the initiatives are like trying to find how to have access of the technology in the classroom, building some maker spaces, bringing in more research, and actually this is what we are doing today, and also finding how to train teachers in using the 3D printing technology in the classroom. Systematic literature review helps to inform the practice and the policies on how to use 3D printing technology. And once these are informed, then we are basically having successful initiative for implementation of the technology. We have some examples here. We have gotten some of the framework for teaching chemistry from the systematic literature review. We have some systematic literature review on teaching biology and also in education in general. Visualization is one part of teaching mathematics, and traditionally it had been through drawing. And with the introduction of technology now, which is 3D printing, visualization is more done by 3D printing. The research that is there about the use of 3D printing, it shows that this is one of the scoping review. This is what we have found, that it focused on the pedagogy, the learning content, that's as you can see, the research methodology, the modeling technology. As we know, the role of the scoping review is just to see or to highlight the trend of what is happening in the research, but it doesn't really give us the concrete evidence of how to improve the policies or practices. Now, so this is where our motivation were, that ideally we expect to have some systematic literature review that could inform the practice of using 3D printing in visualization. Unfortunately, in mathematics, we have already started using 3D printing in visualization, but we don't have the literature that informs us. Then it's likely that we cannot improve our policies and practices. And for that case, our study was based on bringing in the comprehensive evidence on the use of 3D printing technology for visualization in mathematics classroom. How did we do? Basically, we focused on these areas. So the first question was on the learning context. In this case, we were looking if the use is on the regular curriculum or out of the regular curriculum. Then we were also interested to see what are the mathematics contents that are being visualized using 3D printing. On the third and fourth, third one, we were focused on the pedagogical aspects, like how is the 3D printing used, or how do teachers implement the visualization of mathematics with 3D printing. Then we were also looking at the learning outcomes.
what are the learning outcomes when 3D printing is used, then how is it assessed, and what are the modeling technologies that are accompanied with 3D printing. This is how we did. Our database was Web of Science and Scopus, and the search terms that we used for Scopus, search term and techniques, Web of Science. When did we do it? That was, when did we do it? Was 23rd of February. Then the range was from 2014 up to 2024, like 10 years. Then this is what we got as our first result. We had 23 from Scopus, then we have 10 from Web of Science, so the total was 30. Then with the help of Ryan AI, we checked on the duplication. Then we remained with 22. Then after using all the criterias, this is what happened. Then the end result, we had 7 articles, and these 7 articles are the ones that we discussed and used in our study. Well, so in terms of the journal information, that based on the journal, this is what we had. So we had more from IEEE. Based on the country, this is what we had. So more publication were from US, then we had one from German, Mexico one, Bosnia one. Based on the research approach, this is what we had. We had a quantitative 3, then qualitative 2, then experiment, we had 2. Well, so when it comes to the findings, we organized it according to the themes and the questions that we were asking before. So on the learning context, we found that most of the practices are being implemented in irregular curriculum, that is in workshop or summer kind of summer schools. Then when it comes to the learning content, we had some learning across STEAM, volume, geometry, and some of the paper were not like really specific on what was the content. The pedagogy, we found that problem-based or project-based was the dominant one, but also some of the research are reporting the lecture method and presentation method. The assessment, observation to survey is the dominant one, and the spatial thinking tools one. When it comes to learning outcome, we found 4 papers they are talking like they were able to find out like students develop problem solving skills. And the other one, they are saying it improves spatial thinking. And the other one, they are saying it improves conceptual understanding. And when it comes to modeling technology, those are the technologies that has been too much used. Well, so this is our impressions to what we have gotten. We're finding that when it comes to the settings where the research is being conducted, it's not pleasing, and it's very sad because only 4 countries. And if we talk about the global context and the inclusivity, we find as the researchers, we have a really hard time and hard job to do ahead, at least to cover in other spaces and other contexts. The research pedagogy is not really bad, but not also really good. It's a little bit moderate one because if you look what many of the research is, they are reporting that project-based learning and problem-based learning is the dominant one. But still, there are some of the research that are saying teachers are using lecture method and presentation method. As we all know, if they are using project-based problem solving approach, there is high probability that students will be developing problem-solving skills. But if they are using lecture method or presentation, it's likely that 3D printing is not used as it was supposed to be used in the classroom. When it comes to the learning content and context, yeah, the context is too much with a question mark, because if much of the research are showing the practices to be dominant out of the regular curriculum, it implies that 3D printing applications has not yet been taken as a daily classroom practices. It's likely even students and the teachers to keep thinking like this should be done in the extra hours, or it's just extra thing in the education. So in that cases, it's likely that even the policies about how to promote the use could be delayed. But in that case, we need more research. When it comes to the assessment in the classroom, it's also not really satisfying and puts much of the question mark, because the dominant method that the research says is a survey. And we know how tricky survey is. It's either talking more about the feeling of the teacher, not what is happening to the students, but again, it's either students are trying to please the one who is asking. So we would have wanted to see more assessment that are connected with authentic learning in a way that somebody would bring out something that is authentic. What we think is that we need more research in order to support the integration of 3D printing in the visualization of mathematics in the classroom. Thank you, you have revenged. So these are the questions that we think now. That maybe more research should come on specifically on these areas. This is what we think. So if you think you want to do something, you can do that in that areas, or even if you think you want to collaborate with us, you can say, and we are there, we could collaborate in one of those areas. Thank you.
Thank you for your presentation. Questions?
Thank you for your presentation. It was not clear for me if you use the PRISMA statement in your systematic literature review.
Not really.
Okay.
Not really. Would be here, right?
Yeah, yes.
Yeah.
Yeah. Because I have a big checklist.
Yeah, I understand that, but we didn't really adhere to that, because if we were to adhere to that, we had to use the one that is not real, customized as a Prisma 100%, because our study was not more of quantitative, like comparing, you know. So if we were to use the Prisma, we had to contextualize the concept of like comparing. Instead of comparing, it should be context. Do you understand what I mean? Yeah. So that's why to customize it, we had to take some of the aspect, but not use it as a whole.
Okay.
Yeah.
Thank you.
Thank you for your review. It was really interesting. I'm just wondering if you maybe like why did you choose only these two databases?
Thank you.
And why, like I think this visualization could also limit the research, because we did a similar review on manipulatives in mathematics education that actually are used for visualization.
Okay.
And we did it in 2 years ago. And we found 17 papers only on manipulatives in mathematics education. So I'm just wondering, like, your thoughts of the search term and the choice of databases, if this maybe was a bit too limited.
Okay, thank you. So the database was the accessibility. These are the database that we had accessibility with. So that's why. So that's why we went on this. And again, the assumption was that these database are like the most database which are indexed to many journals. So their quality in that feature And our connection with the database is what really restricted us. So Google Scholar, okay, but when it came to the quality of the Google Scholar being connected to many of the journals, it was questionable. Then we were like, okay, sorry, Google Scholar, we won't come to you. Then we went that way. We really focused on the visualization. Oh, so first of all, so we apologize that we couldn't find your paper there, and it was somewhere there. Next time, when we have more access, we'll find probably even the other. When it comes to the terms that we used, especially visualization, we found like when we went with some general terms, we were getting a lot of things that are not really for visualization. So in order to strict ourselves only focusing on the visualization, we had to select more specific terms. Yeah.
I must say that's really interesting, but I've just spotted if you put in visualization with a Z, you will get American ones.
Okay.
English visualization is with an S.
Wow. Interesting.
So I don't know. I mean, I don't know of any research in the UK, but it may be that the alternative spelling might throw up something different.
It's an interesting observation.
Yeah.
So maybe before the final, we could go back again. Yeah, we could go back again with the S and see what it happens. Thank you so much.
Okay.
Some other question? No. Okay, so thank you. And
so now what?
We can continue with the next one. Lucia and Juan, exploring geometric understanding through 3D printing, the Holoid experience.
Okay.
Oh, there are none.
They are online, yes.
Okay.
Can you see me here?
I'm not hearing you.
I hope that you can
Yeah.
look at the PowerPoint. Yes.
Yes, now I can hear you.
Can they see me? They should see me.
Yeah, they should.
Because I have to show them.
Okay. So now, do you hear me? Yes.
Yes.
Perfect.
Then we start.
Yes. Whenever you are ready.
Okay, perfect. I
Yes.
see also the 3 minutes
Okay.
person. Nice to meet you. Then, first of all, we want to thank the organizers for the opportunity to share our experience with 3D visualization and our research into the educational use of 3D printing. This story begins with the inception of a project that engaged over 100 mathematicians, educators, and communicators of mathematics from Spain. The primary aim was to make mathematics accessible through 3D printed materials in educational context, but also in science communication context. In designing these resources, participants of the project drew inspiration on Hans Freudenthal philosophy of realistic mathematics education, ensuring that the materials that we are going, that we develop at the project were connected to these real-life elements, where it's known as modeling in this case. Additionally, the project sought to highlight mathematics with an STEAM context or STEAM perspective. In order to achieve these objectives, we do an extensive bibliography research, and we try to identify these three-dimensional objects that transcended more than two-dimensional representations of an object with height, such as a prince. Then the goal was the truly founding of this object from 3D printing And then we look for many prototypes, and then we decide that the solid that we are going to study is going to be the oloid. The oloid was chosen because the shape and for its unique geometric properties and practical relevance in various scientific and engineering applications. And then Lucia is going to explain this experience of the oloid and what is an oloid.
So, an oloid was invented by Paul Scholz in 1969 as a rotating device. We can see from the picture here that the patent that it is an object with an interesting shape. The goal here is to introduce this object to the students, enabling them to explore and examine its geometric properties. So, the first definition of the oloid is its basic structure. To achieve this, we utilize two discs of equal radius, each with a cut halfway through its radius. These discs then are assembled together while ensuring a 90-degree angle between them. So, thus, our initial questions are about the rotational dynamics of common objects like wheels or balls. Consequently, we delve into the mathematical modeling of these objects and explore some of their functional properties, like the sphere and the cylinder. So, then the first prototypes that we provide to the students are like, for example, one made of thin cardboard. We encourage them to study how it rolls and to examine its characteristics. This version is a bit flimsy, so after many uses, its joint is not stable. So we provide another prototype. This one is the first 3D printed version, and is a simple modeling of the previous disc. The advantages of that is that the perpendicularity of the disc is maintained, but the disadvantage is that they do not always remain attached. So we can make another prototype, and finally we compare with this 3D printed prototype that there are two discs that maintain the union and the perpendicularity of the disc. This version is from Thingiverse, and these students like a lot this version because it rolls very nice. This way, the students can verify the prototype improvement process with these three versions of the basic oloid structure. The prototype improvement process can also be carried out through simulation using Tinkercad SimLab. This allowed prototypes to be tested for gravity and to observe if they roll on an inclined surface before 3D printing. This encourages creativity in student creation and enables performing many quick tests, as you can see in the video here. This is the basic structure, and on the left we have another creativity version of this basic shape. So, how do we transition from the basic structure to the oloid? Well, an oloid is the solid that results from connecting each point of the circle to another with straight segments and filling them everything that remains inside it. So, mathematically, this process is known as convex hull and can be recreated using threads. And we can show the students the picture like you have here at the right. And this way, one can get the idea of the concept, even though it's not a typical content for secondary education. Finally, we arrive to the shape of the oloid. In our case, we print them with the logo of the project mentioned earlier. Therefore, it will be also an opportunity to discuss how the oloid can be designed with the logo. Despite having the logo embedded in it, it does not affect its spinning capability, so it's nice also. The convex hull process can be also recreated, and in general, the oloid or its basic shape can be designed using the BlockSCAD application. This application uses block programming, but employs OpenSCAD code. It contains basic three-dimensional shapes and allows for geometric transformation and set theory operations on the generated geometric objects. For example, the versions we have in blue will be two of those we printed for this activity. And then we printed the alloys split in half to avoid generating support material. This way, the two halves were simply glued together. For good spinning capability, we printed them at 5% density instead of the usual 20%. For better development of the activity, each student has one alloy and two discs of each type to create different prototype versions. This material is very durable and has allowed us to carry out the activity on several times. This material is, as you know, PLA, like usual PLA. Once the students have the complete alloy, they can roll it and compare it with the exploration previously done on its basic structure. The sequence of questions then focuses on exploring more properties such as its symmetry or even discussing how it can be printed. As I don't know if you can see, it maintains the mark that two halves have been printed, which always awakes their curiosity, and they always ask for it. Other questions focus, for example, on the path it traces on the plane. So, speaking of paths, it's easy to imagine the path traced by a sphere or a cylinder, but it's fascinating to consider the one drawn by an alloy. We encourage students to imagine that this path looks like by rolling the alloys on their hand or drawing the trajectory on a piece of paper. Usually, there are always several students who have the correct intuition before seeing the solution. The entire surface of the alloy touches the ground at some point while rolling. Therefore, as we can see in the Technorama video, the alloy, when rolling, traces its own folding net. And thus, this is another property that the students are fascinated to discover. So in real life, let's remember that Paul Schoch invented the alloy as an object with a special twist. This patent is used to create machines that serve as a fluid agitators to clarify water. And you can see in the videos, there are actually right now utilizing in some points of the planet.
The experimentation conducted with the students has showed that an improvement in their visualization skills. Also, observations that we realized have indicated an enhanced proficiency in the use of three-dimensional vocabulary, as opposed to the traditional two-dimensional terms expressed by students. They were able to manipulate the alloy to better grasp geometric properties such as convex hulls, trajectory graph, and the concept of rolled surfaces. Furthermore, this experience has been educational both for the teachers that use the project materials and also the students in learning about 3D printing processes and 3D modeling technologies. Educational institutions that participate have developed complementary strategies that have deepened their understanding of the design of the alloy and its generation circles using software tools like Lucia showed, Tinkercad and BrosCAD. This hands-on approach not only facilitates a tangible interaction with complex mathematical concepts, but also fostered an environment of active learning where theoretical knowledge was applied to practical, real-world tasks. Here, shown by Lucia, the quest for a three-dimensional object with applications in engineering and other fields such as art underscores the significant role of mathematics within initiatives that cultivate STEAM skills. The incorporation of modeling and 3D printing processes into our project has enabled participants to visualize how the study of mathematical properties connects with real-world problems, aligning with the philosophy of realistic mathematics education. The capabilities for prototyping and creation provided by this three-dimensional object has also enhance innovation and creativity among the students involved in this project. Furthermore, tackling mathematical problems based on the properties of three-dimensional objects has advanced their mathematical visualization skills. In future work, we are keen to analyze these improvements in visualization skills in greater detail and also in spatial thinking abilities. Additionally, we aim to continue exploring the development of modeling skills among secondary education students through activities and experiences similar to those that we present around the holoid. In conclusion, we hope to continue this cycle of design and enhancement of both three-dimensional objects and our research into the use of 3D printing in education. Thank you very much for your attention.
Thank you for your presentation. Now, do you have questions?
May I have a question?
Yes. Say yes.
Yes, yes. Sorry.
Hi, well, good morning or good afternoon. I really like this work and this presentation. Thank you for sharing this nice idea. I was just wondering if you are in contact somehow with the work of José Manuel Arranz. He's doing some nice representation in GeoGebra to show how it works. So maybe you can explore in this sense to spread the idea of the animation.
Yeah,
So,
nice. Thank you. We have, as you can see at the presentation, we have the 3D model of holoid in GeoGebra 3D, and we have been working with that. We ask to the students questions around, you know, like as it's this longitude areas and everything around the holoid. In this GeoGebra 3D, but no, we have not studying in this. We cannot deep in GeoGebra 3D representation. We have been more interested in modeling in these CAD programs. But thank you.
okay, yeah, I mean just to share the visualization to some others. So I share with you in the chat the link, so he has nice words relation to this. Thank you.
Thank you.
Thank you.
Some other question? Maybe from online again?
Yeah, I have one.
Sorry, I didn't catch if you are doing this. You are doing this in the school with which level? Where?
Well, thank you for the question. As we mentioned, we have been doing this at secondary level. We have been from 12 to 16 years, and we have been doing this also in communication of science moments that we have been working in workshops where talented students or other type of students are interested in enrichment curricula workshops. And then, but the study that we are going, that Lucia is going to it's impressed now. It's centered in secondary education at around the 15 and 16 years.
But we also did once in primary education about 8 years.
Since this was a project that many educational centers have been reproducing in their then has been used in many ages, different ages.
Yes.
Great, thank you.
Okay. Is there some other question? Then thank you for your presentation.
Thank you also.
And now we can continue with the last presentation. From playing to modeling a 3D experience with Genius Square for fostering spatial thinking and combinatorics by Diego. Is online. Okay.
Hello, morning. Can you
You can
hear
start.
me?
Yes.
Yeah, perfect. Thank you.
Okay. Well, first of all, thank you very much for this opportunity. Thank you, Matthias, Cecilia, and the others who are supporting the organization of the event, Eva as well. So basically, today I'm sharing some ideas that I have developed during my visit in Linz last January. So we were working on this STEAM lab. And I was developing some 3D game, the Genius Square, with the help of Matthias and Selen and some other colleagues as well. So we were trying out to spread a bit this idea with Joel as well. So basically, I'm interested in this point because I can see different opportunities to work with it, especially with 3D visualization and spatial thinking and combinatorics that are some topics that I'm teaching usually. In Brazil, I'm teaching for future teachers, but I'm also teaching for high school students. So I'm really interested in these two topics. So far, I'm using this 3D printing and laser cutting to develop some STEAM activities in my institution. So I can see STEAM as a creative practice by using digital, non-digital, and hybrid resource combined. So here I'm showing you some possibilities in different sense. Not only in math, but connecting to some other subjects like physics, arts, biology, or chemistry, for example. But the most important point from my point of view is all of these projects are developed by students. So here you can see some puzzles and lamps based on arts developed by high school students. Something important to say in this kind of work with projects is we are looking at different directions, not only with 3D printing, but also combining laser cutting, augmented reality, and some other resource. But from the conceptual point of view, we are using these 4 C's: creativity, critical thinking, and communication and collaboration. These 4 C's as important soft skills for the 21st century education. So more in deep in this game design approach, I can see some possibilities in the modeling process for sure, but also from the playing perspective, when the students are playing, they are trying different positions, let's say, from some piece. So here you can see a game that is based in this kind of exchange of pieces. And this is really good for combinatorics. Here, I'm sharing another example. Is the Quarto game is based on the tic-tac-toe, but in 3 dimensions. So we have worked on this game either in the modeling process, I mean to develop these 3D pieces, but also from the coding perspective to to work on it in GeoGebra to modeling this coding. So we are supporting this computational thinking, for example. Also important to say here, they were working on this laser cutting to develop the box of the game. So here I'm spreading different games that we are working on it, but I'm jumping a bit, so you can see some different ideas. But some of them are connecting the physical and digital version, or a hybrid version could be in some sense. So it's a way to democratize the opportunity of students to playing with it. Some students, at least here in Brazil, that have no opportunity to play online because different reasons, by the connection sometimes, or the resource. So it's interesting to support them with the physical material. On the other hand, sometimes it's the opposite. It's easier if they have the online version, they can play on their hand with their mobile phones. So here another game, it's the Logic Faces. We are combining the digital and non-digital versions. The Autrio one. So you have also an online representation on GeoGebra, but also the physical version. We are spreading this in different events, so it's not limited to the classes, but we are spreading to informal space of learning. Pentago is Peg Solitary. Rubik's Race that we have adapted for playing with a hybrid version. So basically we are substituting the dice for GeoGebra shuffling material. I'm spreading soon in the Genie Square. The set game is one of those I have adapted for 3D version, so we can develop the spatial reasoning playing with this. And finally, the most important, the Genie Square. So this is a quite new game. It seems to me it was invented the last year or 2 years ago. And so what we were doing was spreading it in some workshops, either with kids or teachers or researchers. And I'm sharing quickly a bit of this experience. So here on the top right, you can see GeoGebra version, but it's not to play online, but just to shuffle the black pieces. So basically, this game works with the Tetris pieces. So the idea is shuffling the 6 or 7 dice to block some coordinated squares. And based on these first blocks, we have to distribute or fit the other pieces. It's quite simple game. It's a solitary game. It's a challenge. But the idea here is thinking about how many possibilities, for example, we could work with it if we have different possibilities. We could investigate some kind of different possibilities. Of course, kids have a lot of fun playing with it. So in January, we took this game for a workshop with kids, and they were really interested not only by playing, but also by modeling this game on Tinkercad. Thanks to Prusa, we have printed out this game, and the idea is sharing the models in this printable platform provided by Prusa. I have seen Gidi has presented already. So little by little, we are improving this platform as well. And here it's another workshop we have developed in January with teachers. So most in the sense of engaging them to feel more comfortable in working with such kind of technology, because there are a lot of resistance sometimes by teachers to work on this kind of modeling, 3D printing, and novelties in general. So it was a easy way, I mean, to get them involved. First of all, playing with the game, and then discussing the strategy to model it, because basically it was totally based on cubes. So we have basically to connect some cubes to produce the pieces, and of course the cylinders. But it's really easy to do it on Tinkercad. So we were in this Abe school in Linz, and they have this lab, this maker culture lab, and some 3D printings there. So we were playing first and then modeling it, and finally printing out. And the last workshop that we have done in Linz was with some researchers who were there as well. So we were discussing some possibilities to use this game in schools. So in this case, we have different small boards, like this one that you can see in the pictures. We had in 2 different scales. So this is something interesting to discuss with students as well. For example, regarding the time to process, to print out, which kind of math is behind this time consuming, for example, and volumes, and so on. But the most important thing that came out during this process with researchers was really interesting, was regarding the recognition of patterns. We have observed there are many different solutions for the same combination. So we were playing with 5 or 6 players and researchers, and we realized there were different solutions, as you can see in the right bottom picture. And this is something interesting to discuss with the students, because basically mathematics is based on patterns and recognitions as well. So, and something else that I'd like to mention here, even though we were playing in these small boards, when I came back to Brazil, I have developed, maybe you can see on the screen, I have developed a bigger version. So if we compare with the small one, is this size and this size. And here I'm combining the board with laser cutting material. So it's an opportunity as well to combine different technologies as well.
Excuse me, Diego.
Yeah.
You have less than 3 minutes.
Okay, it's more than enough. Thank you. So by playing, what I have seen is some opportunities to explore combinatorics, spatial reasoning, symmetry, patterns recognition, and coordinates with this game, for example. By modeling, I have observed some measuring process, some percentage, ration and proportion, geometry in different sense, so like rotation, parallel lines, extrusion, and so on. And by the process of 3D printing or laser cutting, we can discuss different concepts as well, like density, ratio as well, volume functions, connecting speed and time consuming and filament needed and volume and so on. So different opportunities to investigate and to use math on it. So here I'm just showing you some reference that I'm using. So from Yuval Harari, the 21 lessons for the 21st century. Kindergarten, lifelong kindergarten from Resnick. We are all creatives and creative intelligence. Sorry, I didn't change for the English version, but I'm using the Portuguese versions here, and some Fab Labs reference that I have in Brazil as well. So thank you so much for your attention. And here I have some links. So if you are interested on it, you can check later. Thank you.
Thank you for your presentation. Now it's time for questions. Do anyone have a question? No?
Hello, Diego. Thank you for your presentation. You said you worked with researchers as well as the students. Could you tell us what are the lessons that you have learned from the two groups?
Yeah, for sure, we have different perspectives working on it. From students, we were more in the playing side. So I was even more observing how they explore the game, how they interact with the game. Even though one of them was really deep on this modeling process, I was even more working on playing with them. But something interesting that happened not in this workshop that I have showed to you in the pictures, but here in Brazil later on, was regarding the critical thinking. So I was sharing this game with a little one, like 5 years old girl, and just for fun. And of course, I was not intending she could play as the game completely. I mean, with the whole rules. But I just give the game to her and told her, well, try to put the pieces as much as you can on the board. And at the end, she managed to do something like that. But there were some spots available, and she couldn't fit this one. And then she put like this. And I got really glad with this because it was regarding critical thinking. She was not limited to put the piece as we usually think in this position. But she was intending to fulfill the conditions that I asked to her to put the piece on the board. So this is something interesting from the student's point of view. From the researcher's point of view, we were discussing strategies to use the game. So as I mentioned before, for example, regarding the process of modeling or the patterns that we can recognize and so on. So it was more in the methodological side. And thank you for your question and your participation as well, Musa.
You're welcome, Diego.
Hi, Diego. I have a question.
Yeah.
You collect people, but why are the arrows in the other direction? No, I just started in the wrong place. You start with research and not with the prototyping.
Sorry again, I didn't get the arrows. Which one you mentioned?
The slides that you just showed previously.
Yeah.
The last one. Last one.
The last one.
The final one.
This one?
No.
Final.
Keep going.
That one. You start with researching and not with prototyping, right?
Well, sorry, I didn't explain this one. This is connecting the project that I'm leading in Brazil. It calls PIPA. So PIPA means in Portuguese, research, innovation, prototyping, and learning. So it's just to explain the logo and the name of the project. It's not connected to this project specifically, but you are right. I'm not starting from research in this point. I'm even more using the game spontaneously and then investigating the possibilities. So, but it's not connected to these arrows. These arrows is more to connected to the project that I'm leading here in Brazil.
Okay. Thanks. That got me confused.
Sorry. Thank you.
Maybe some other question? No? Then thank you for your presentation.
Thank you.
So if we don't have any more questions, it's time for closing this very interesting conference. Thank you, Diego.
Thank you.
So for that, I will let Scholl to do it.
Glad to see you, Selay. Kisses to all.
Selay already left to the airport.
Okay.
Hello. So, thank you very much for the last.
Diego, thank you for the reference. We know Jose Manuel Arranz, but he's from another part of Spain, and that was the reason that we didn't observe it before. Thank you. I'm sorry, I am not able to listen to you.
Sorry.
And I think that we have to close because this is also on YouTube. Then we are speaking